assessing modularity using ModularityCheck. In this video, I will present ModularityCheck tool. This tool aims to support on assessing package modularity. According to Parnas, modules should hide important design decisions or decisions that are likely to change. So we consider a module as a responsibility assignment. Our goal here is to analyze if the classes that usually tend together are in the same package. ModularityCheck helps us to understand and to assess package decomposition of a target system. This is ModularityCheck, a plugin for Eclipse that uses evolutionary information. So to run our tool, we need to set up some parameters. First, we have to inform which issue tracker and which version control system the target system uses. Second, we need to inform the repository address. Third, we need to inform the issue report location. Here, I'd like to emphasize that the issues have to be saved in XML format. Finally, we need to set up the time frame that the tool will consider to extract information from version history. After setting up these parameters, we have two filters, maximum scattering and minimal cluster size. The default values is 10 and 4. Maximum scattering filter prunes highly scattered commits because these commits usually are related to refactoring activities that code removal, and these activities don't represent a recurrent maintenance task. And the minimal cluster size, here we have the value is 4 by default. This represents that, for example, if the tool will select a cluster if it contains at least 4 classes. Here is the information about the clusters. We talk about cluster size, cluster density, cluster average edges weight, cluster focus, and cluster spread. Let's run now an example using Geronimo, web application system. Now we have a distribution map and the metrics for Geronimo. Let's go to understand the distribution map. The larger squares represent packets, the small squares represent classes, and the colors represent clusters. Distribution map provides two metrics, focus and spread. Focus measures what percentage of the package the cluster touches, and the spread measures how many packets are touched by the cluster. We can observe here that most of Geronimo's package contain a single color. This suggests that Geronimo is well modularized. From these clusters and from focus and spread, we can detect some kind of patterns. For Geronimo, we detect two patterns, clusters well encapsulated and clusters partially encapsulated. Let's see an example. Let's see cluster number 7. Its focus is high, its spread is 2, so this cluster is partially encapsulated. We can see here on distribution map that this cluster touches the whole package in a package model and touches a single class in package Tomcat. This pattern suggests that there is a possible ripple effect between these two packets. Let's go now to see another type of pattern, clusters, and cluster number 5 that is well encapsulated. Its focus is 1, its spread is also 1, and here we have the cluster number 5. Cluster number 5 touches the whole package male. This means that these classes usually tend together and these classes are confined in the same package. So this package is well modularized. Now we will do another test. We will analyze the Lucene system, a text search library. Here we have a distribution map for Lucene. We can observe that the clusters are scattered over the packets. In Lucene, we could detect several different patterns. Clusters partially encapsulated, well confined, clusters with cross-cutting behavior, clusters well encapsulated. Let's see a different example. Let's see the cluster number 3. Cluster number 3 has a high focus, its spread is 1, so this cluster is well confined. Here we have the cluster number 3. The cluster number 10, we can see that the focus is lower and its spread is also 1. So this packet perhaps could be divided into sub-packets. Let's see another example. Cluster number 9. Cluster number 9, the focus is very low. Its spread is 3. This cluster has a cross-cutting behavior. This cluster touches 3 classes in the package index and touches a single class in the package analysis, and also a single package in package store. So here I finish my presentation. Thank you.